Good morning, my little lemon drops. So today we are going to be going over all of 9.3, which is about naming and writing formulas for molecular compounds. Just so you know where we're at, this is our lovely list of things that have rules for being named. We've gone over all of these things so far. All we have left to name are organic or molecular compounds, covalent compounds, which we will be doing today, and then we will start doing naming for acids and bases tomorrow. So we are very close to being done with chapter 9, meaning there will be a quiz coming up. I'll let you know when we're done with this chapter what day that quiz will be. Thank you to those of you who followed directions yesterday. I love when people can follow directions. It makes me very happy. Alright, so let us begin. This is going to be kind of a short-ish lecture, and then you'll work on the assignment for 9.3, and then you will begin taking notes for 9.4. Alright, so organic compounds are also known as covalent compounds, are also known as molecular compounds, so those are three interchangeable words, organic, covalent, and molecular, when we're talking about compounds. Alright, so we are only going to be learning how to name binary molecular compounds today in this chapter, actually. So binary molecular compounds are molecular compounds composed of two types of elements, both of which are nonmetals, and they are not ions. Alrighty, so these types of compounds are composed of only two types of elements. There's only two types of elements. So we're going to see that if we're not going to be naming compounds with three elements, for example. It's only two types of elements. And these two types of elements are both going to be nonmetals, so they're going to be on the right side of the periodic table, and they're not ions. There are no ions in anything we're doing now. We've already learned how to name all the ions we're gonna see. Okay, so when these two nonmetallic elements combine, they do so in more than one way. So let's look at some examples here. You know a lot of examples of binary molecular compounds. We have carbon monoxide, CO, and we have carbon dioxide. So these are both binary molecular compounds composed of carbon and oxygen, but they have different molecular formulas. So this might seem like we're making a big deal out of nothing. Like, why does it matter that we are so specific about the names? Like, why can't we just call both of these carbon-oxygen and carbon-oxygen? Because CO2 in small amounts in the air is no problem. There's small amounts of CO2 in the air that you're breathing right now. We breathe out carbon dioxide. So little amounts of carbon dioxide in the air, or even a little, small amounts. It's a small amount, the amount that you're all breathing out and breathing back in each other. You're all breathing in each other's breath. How gross. But anyway, we're breathing back in a little bit of CO2, right? But in this small amount, it's not a big deal. It's not hurting us at all. But if we had small amounts, the equal amount of CO in the air, carbon monoxide, you would probably all die of asphyxiation, which is basically suffocation. It's a poisonous gas. CO is a poisonous gas, and it blocks your blood's ability to carry oxygen. So blood is like a little circle shaped like this, right? This is like a side view of a red blood cell, and an oxygen molecule, O2, fits perfectly in there so that these blood cells can carry the oxygen all throughout the body. But when we have carbon monoxide, what happens is carbon monoxide attacks and sits here and blocks red blood cells from carrying oxygen. So you would basically, if we had the same amounts of CO in the air that as CO2 in the air right now, you would all basically suffocate. So it's very important that we specify which carbon-oxygen compound we're talking about. Another example would be water and hydrogen peroxide, H2O and H2O2. These are both binary molecular compounds, and you could drink a liter of water, and you should drink a liter of water to stay healthy, but if you drink a liter of hydrogen peroxide, you're going to be very, 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 very sick. So it might even kill you. I'm not 100% sure. Never tried it, obviously. So again, another reason why we need to have a set of rules for naming these two things, so we can, or these not just two, there's many different types, but for naming these binary molecular compounds so we know which compound we're talking about. So let's look at the rules for naming, and then we'll look at the rules for writing the formulas. So first we're going to look at naming rules. The first rule is to write the names of the elements in the order that they're listed in the formula. All right, so there's our first rule, and I should say we're naming binary molecular compounds and this is when we're given the formula. Obviously, we can't name something without knowing what we're naming. So we're given the formula and we're writing the name. These are the rules for doing that. All right, so there's the first rule. The second rule is we're going to use prefixes to indicate the number of each kind of atom. And there are some specific rules for these prefixes, and there are some prefixes that you are going to need to memorize. So we need to look at what the prefixes are, but I'm going to write down the rule first. Here's the rule. All right, so there's the rule, and here are some two little sub-rules that I'm going to come back to when we do, once we look at our prefixes and do an example. So our prefixes, we're going to look at our prefixes. They're over here. So our prefixes, I'm going to just write them all, and then I'll give you some examples. Our prefix for 1 is going to be mono, and for 2, it's going to be di. 3 is tri. 4 is tetra. 5 is penta. 6 hexa. 7 hepta. 8 octa. 9 nona. And 10 deca. Okay, so if I what this means is, let's look at H2O2. Okay. H2O2. They both have a 2 subscript here. So that means we're looking at the di prefix. So this, based on our rules that we're still writing, we would have dihydrogen dioxide. Dihydrogen dioxide. If we have HN3O4, we're going to add a prefix every time that we have these subscripts, okay? Or even if we don't have subscripts. So N3O4. N3 would be our tri, so this would be tri-nitrogen. And then we have a 4 here in our formula, so this is going to be tetroxide. We don't say tetraoxide, we say tetroxide. All right. So here are two, I'm showing you how we use we're going to do way more examples than this, so don't freak out. These are just the prefixes that you're going to need to know. So I'm not giving you these on the quiz. You need to memorize these 10. They're pretty simple. So there's our second rule. Our third and final rule is that we need to give the second element the suffix "ide." So we're going to end the name of the second element with the suffix the IDE suffix. Okay, so let's look at a bunch of examples using all of these rules here. All right, so here are our 4 examples we're going to look at. Let's do this one first. So we have 2 chlorines. So what we're going to do is we're going to write the names of the elements in the order that they're listed. So it's going to be chlorine, oxygen. So to start, before you get really good at this, you can literally write out chlorine, oxygen, if that's helpful for you. I've been doing this for many years, so I don't need to do that, but if that is helpful for you, that's how you should do it. Then you're going to use the prefixes that we learned above to indicate the number and the type of each atom. Get our prefixes there. Okay, so we have 2 chlorines. So if we look at our prefixes, 2 is di. So this is going to be dichlorine. And then we're going to look at our oxygens, and that is 8. So I erased it because I'm not going to have room. So 8 is octa. So when we have, if you look at this little, up here, this exception that I made, it says drop the vowel at the end of the prefix if the element name begins with a vowel. This isn't always, we're going to say sometimes, because we're going to see it's not always 100% of the time true. For example, with di and tri, it would be dioxide and trioxide. But with tetra, penta, hep, with all the rest of them, we would drop the A. So let's say you could make a little note here. We'll say except with di and tri. Because, like I said, we would say tetroxide. We wouldn't say tetraoxide. It would be tetroxide, pentoxide. So for this, the example we're doing here with 8, our prefix is octa. So we would say OCTA, but we're not going to say octaoxide. That's just so yucky, and it should feel dirty in your mouth and not right in your mouth. So we don't write octaoxide. We say octoxide. We drop the A, right? Because this is one of those ones that is any of the others besides di and tri, right? Octa is not di, it is not tri, so we drop the A. So the name of this element, and obviously I got ahead of myself. We have oxygen. This is not right, but this is how it would be if you were just adding the prefixes, if you're just learning how to do this. So that we have dichlorine, octoxygen, but our third rule says that we end the name of the second element with the "ide" suffix. So instead of oxygen, we would say oxide. That's why I had IDE here. Okay, so this is dichlorine octoxide. That's the name of number 1. Dichlorine octoxide. All right, now let's look at number 2 here. Number 2 is OF2. So we have a special, let's write it out. So write the names of the elements in the order that they're listed in the formula. So we have oxygen, fluorine. All right, the second rule says to use the prefixes to indicate the number of each type of atom. But we have an exception when we have only one element. So it says to omit the prefix in the first element if there's only one atom of that element. In this case, we don't have a subscript for oxygen, right? Because there's only one oxygen. So here we do not write monooxygen. We're never going to write mono monooxygen if it's the first element. If it's the second element, like we're going to see down here, we're going to write mono or mana. But when it's the first element, when we have only one of the very first element, we just write that element's name. We don't need to write mono. Okay, I'll give you another example right after this. Well, actually, really quick, another example is CO2. We don't say monocarbon dioxide, right? We don't say that. We just say carbon dioxide because the first element has only one atom of that element. So same situation goes here. So we have oxygen. We're not going to write monoxygen. We're just going to write oxygen. So moving on to the next one, fluorine. Fluorine has two, so it's going to be difluorine, but we're going to get rid of the INE ending, and we're going to replace that with an IDE ending. So that's going to be difluoride. Oxygen difluoride. That's the name of number 2 here. All right, number 3. We have sulfur and fluorine again. And I'm going to put my prefixes. So I have 6 sulfur. So this is going to be hexasulfur. And I have 10 fluorines. So that's going to be decafluorine, but it's not going to be decafluorine. It's going to be decafluoride. So I erase that, and I'm going to say hexasulfur, and I'm writing it undersoy fluoride, so I can fit it here. So I can fit it right there. So that is hexasulfur, yep, 6 sulfur, decafluoride, 10 fluorines. And finally, number 4, so in this situation, we have nitrogen and oxygen. We have 2 nitrogens, so this will be dinitrogen, and we have 1 oxygen. We have to indicate that it is 1 oxygen here because we can only drop the prefix when it's the first element listed that has only 1 atom. In this situation, the first element listed has 2 atoms of nitrogen here, right? And so, well, this is the second element listed. It's not the first element listed, so this rule doesn't apply to the second element listed, only the first rule, or first element. So this is going to be mon, and it's not di or tri, so we drop the O at the end, so it's going to be monoxide, because it doesn't make sense that it would be monoxide like that, right? Monooxide, that doesn't make sense. It just looks, you can just tell because you have a level in English that you know that that's not correct. So here, the name of number 4 would be dinitrogen monoxide. Okay, so these are just some basic examples of how to name binary molecular compounds if we're given the formula. Now let's look at the rules for writing the formulas if we're given the name. Writing formulas, given name for binary molecular compounds. So this is basically, we're going to just use the same concepts as the rules for naming when we're given the formula. So the first rule is to use the prefix of the name to tell you the subscript of each element in the formula. And the second rule is we're going to correctly write the symbols for the 2 elements with the appropriate subscript. So this is obviously less rules. All right, so pretty simple. Let's look at some examples here. So let's look at, I'm going to just write some examples. Alrighty, so let's look at these examples here. So we have nitrogen tribromide. So nitrogen, that's easy. We know that because this doesn't have a prefix, that there's no subscript for nitrogen, right? Because of our rules above. Remember, we omit the prefix of the first element if there's only one atom. So since this doesn't have a prefix, it must be only one, and we don't write a subscript of 1 here like that, right? So we have nitrogen, tribromide. So we have NBr, and our prefix tri is 3. So NBr3 is our answer for number 1. Number 2, dinitrogen. So we have nitrogen again, and we have a 2 as a subscript. Pentoxide. We have O, oxygen, and 5 for penta. Then we have trisulfur noniodide. Wow. So we have trisulfur, so S3. Nona, remember, is 9, so we have iodine with a 9 subscript. Then finally we have chlorine nonoxide again. So we don't have a subscript here for chlorine. We don't have a prefix for chlorine, nothing in front of the chlorine. So we know that means there's just one chlorine, but we don't write 1 as a subscript, just like we don't write 1x when we're doing math. So we have chlorine, 1 chlorine, and oxygen. We have nona, so there are 9. Okay, so that is these are the rules for writing the names and the formulas for binary molecular compounds. You're going to need to understand and memorize these rules, and definitely just memorize these prefixes, these 10 prefixes. You're going to need to have those in your brain for the quiz. Alrighty, that is it. So for the rest of the period, you can work on the 9.3 questions doc that's on Google Classroom. And then if you get finished with that today, since there's quite a bit of time left, you can begin working on the 9.4 reading and notes, which are due tomorrow by the start of class. Both of these assignments are due tomorrow by the start of class. Please let me know if you have any questions. I will get your quiz corrections graded this weekend. So if you're waiting for those, don't, because I'm not going to get to them till this weekend. Please let me know if you have any questions. Thank you. Have a good day.